Before we define RAG, let's start with one simple question. Imagine you ask an I, what is our refund policy? At first, this looks like a simple question, but there is a hidden problem. The answer is not inside the question. The answer is inside a document. Maybe a PDF, maybe a company policy file, maybe a Notion page, maybe a database. So the real question is not, can the I write an answer? The real question is, where will the I get the knowledge from? A normal language model is very good at generating text. It can write clearly, it can summarize, it can explain, it can reason over information you give it, but it does not automatically know your private documents. It does not automatically know your latest company rules. It does not automatically know the PDF you uploaded yesterday unless that information is placed into its context. So when the model does not have the document, it may still produce a confident answer. But that answer can be a guess. Here is the missing piece. The answer exists, but it is sitting outside the model. This is the main reason RAG exists. RAG is not trying to make the model memorize every document. Instead, RAG creates a path between the user's question and the right external knowledge. That path is the retrieval system. RAG stands for Retrieval Augmented Generation. That sounds technical, but the idea is simple. Retrieval means find the useful information. Augmented means add that information to the model's context. Generation means let the model write the final answer. So RAG is a two-step system. First search, then answer. The first part is retrieval. The system looks at the user's question and asks which pieces of information are most relevant. It does not send the entire internet. It does not send the entire company folder. It does not send every page of every PDF. It searches for the small pieces that are most likely to answer the question. For our example, it finds this line, refunds are allowed within 14 days with proof of purchase. Now the system has evidence. The second part is augmentation. This means we take the retrieved evidence and attach it to the user's question. So instead of asking the model, what is our refund policy? We ask the model with context, here is the relevant policy text. Now answer using this information. This changes everything. Now the model is not guessing from memory. It is answering from evidence. The final part is generation. Now the LLM does what it is good at. It reads the question. It reads the retrieved context. Then it writes a clear answer. This answer is better because it is grounded. Grounded means the answer is connected to a real source. The model is not just speaking from probability, it is using retrieved evidence. So the simplest mental model of RAG is this. A user asks a question. The system retrieves relevant information. That information is added to the prompt. Then the LLM generates an answer. That is RAG. Not magic, not training the model again. Not uploading a PDF directly into the model's brain. Just a smart pipeline, question, search, context, answer. This is very important. RAG is not the same as training. Training changes the model's internal weights. That can be expensive, slow, and difficult to update. RAG does something different. It keeps the model the same. But before each answer, it finds the right external knowledge and places it into the prompt. That means if your document changes, you do not need to retrain the entire model. You update the documents. Then retrieval brings the new information when needed. RAG matters because most real-world AI applications need knowledge that is not inside the model. Customer support needs company policies. A legal assistant needs case documents. A medical assistant needs trusted guidelines. A business assistant needs internal files. A student assistant needs course notes. In all these cases, the model alone is not enough. The model needs the right information at the right time. That is exactly what RAG provides. So, what really is RAG? RAG is a system that helps an AI answer using external knowledge. It first retrieves relevant information. Then it gives that information to the language model. Then the model generates a response based on that context. The key idea is simple: don't ask the model to guess. Give it the right knowledge first.